Hey, Brian.
Hey,
Hey,
Sean.
Bobby.
Hey, good. How
Hey,
are you?
Sean.
Hey, Bobby. How's it going?
Doing well, gentlemen. How are you?
Pretty good.
Are you getting any echo from me?
I'm not, no.
No, it sounds good.
Yeah. Try and set this up to auto admit everyone. I can never find how that, it's like one of those things. You always find it once. And then where it's at is always elusive thereafter.
I like your shirt, Sean.
Oh yeah, thanks. This is something that gets more comments than any other item of clothing I own. And comes from a company called Liquid
I can
Blue.
imagine
I
why.
don't know if they're still I don't know if they're still in operation, but they were an online t-shirt company back in the day, and I did some consulting work for them, and the owner said, "Oh, as a thank you, go and pick out a dozen t-shirts." And he sent me 2 of each of a dozen t-shirts, so that was kind of cool.
Yes, they are.
Oh, that's cool.
Yeah, my wife has a bunch as well.
No, they're still around.
Oh, okay.
Liquidblue.com. There they are.
Okay.
That's funny. I live almost entirely in conference swag now. That's
Yep.
you go to conferences and I don't have to buy clothes anymore. I never look great, but don't have to buy anything. This is my Kafka Summit shirt.
Ah, nice. What conference was that?
This was Kafka Summit.
Okay.
Was that the recent one?
Yeah.
Oh, right. Yeah.
All online.
Yeah, I went to a few of the sessions online, and I'm supposed to go back and have a look and watch some more of them that I was interested in. I just haven't found time yet.
Yeah, this is going to be a bit of a this talk at this meetup will be a bit of a rehash of my talk at Kafka Summit.
Okay.
If you saw that one, I don't know, spoiler. you may know some of this stuff already.
That's okay.
No, I heard that was a very good talk from one of my colleagues that you gave on the Kafka architecture. So yeah, he was hoping that it would be that talk.
Yep, I haven't had time to put together another one, so you get the talk that I give this year.
Right? You do a hit once, why re-record it?
That's right. It's like Billy Joel. You just keep rocking those same songs,
Do it over and over. Sorry guys, I'm trying to find I know somewhere there's a setting so that I don't have to check the meeting room or the waiting room, but I can't find it. So I will just pay attention and quit trying.
Hi, Madison.
They keep changing the setting, I think. We've run into this at work where we managed to get it so that people who sign in on the work domain don't have to be admitted, but we still have some people who are using a Zoom account that they had prior to us getting a corporate one, and they all still have to be admitted even though we keep changing the settings. So, yeah.
It's not in the, it's not in the help. Okay.
What have you been working on lately, Sean? Anything interesting?
What have we been doing recently? We've been setting up a lot of machinery to auto screen photos and auto screen profiles. So we've been dealing with image analysis software and services, and a lot of fun stuff like that. And definitely AI and ML is still a long way behind what they promise you.
Yeah, you hear a lot of big words these days about AI and ML. It's still barely indistinguishable from statistical techniques I was using in college, So.
Yeah, they've just made the APIs a lot easier to work with.
Yeah, yeah, right. You have to drop down into MATLAB or one of those to do this stuff.
What was it? So it does auto analysis of profiles, Sean?
Yeah, I mean, we're an online dating company.
Yeah.
So we've been working. We've always done very manual moderation of everything, and we're looking to do more and more automated moderation so that our member services team can focus on dealing with customers more than just moderating profiles and content and images.
So it's looking for like graphical content or things that are offensive?
There's all sorts of things, face detection, text detection, analysis for age, ethnicity, all sorts of things are possible now. Some of them work better than others. Text detection works really well these days.
Okay.
It can pick up logos on people's shirts. It can pick up signs in the background. If they have a selfie that's taken out on the street somewhere, it'll pick up the road signs. So yeah, that part works well. The face detection and some of the other stuff around that, not so well still.
Okay. I should connect you with my friend Lauren. He's at HireVue, and he said they pick up like, I think it's 25,000 signals off the face. They have a really super sophisticated like facial recognition and processing system, but I know it's built off of all open source components. And he found a ton of data that like from just disparate kind of projects and programs that he was kind of able to integrate into one cohesive kind of platform. So yeah, it's pretty cool. There should be, I'm hoping there'll be a lot of like, kind of, they put the LiDAR detector, they put it in the back of, I think it's in the new iPhone. I don't know if it's in the front, but it's in the back. And I think like some of the things, so some of the problems we had were like, we were doing an analysis of this girl that might have tardive dyskinesia, and she had a picture of Paul McCartney behind her, but it was just at such a size that it looked like they were sitting right next to each other, and the algorithm kept getting confused. It was literally, you could see it like going back and forth as to whether it was to analyze McCartney or her. But it's like with the laser rangefinder, the true depth camera, these kinds of things. Like you can get a matrix of continuous depth points, right? Data points, and from then okay, Paul McCartney's way back here. I think that one we were using OpenFace, which was it's pretty good. It's better than the one that comes by default in OpenCV.
Had a whole bunch more folks join.
Yeah,
Hi, Peter, Simon, Madison, and her baby. That's awesome. Hi, baby. Our youngest Clojurist on the call.
Got to start them early.
Right? Hey, Peter, how's it going?
Good evening. Good, Brian. How are you?
Hey, pretty good. Hey, so yeah, it looks like we got a quorum. Should we go ahead and get started?
Sounds good to me.
All right, cool. Yeah, so I don't know if you guys had a chance to read Bobby's bio, but he's an architect. Maybe Bobby, I'll just let you kind of introduce yourself.
Hi, sure. So relative newcomer to Utah. I assume everyone's local-ish. It's hard to tell anymore since everything's, remote. But just moved to Utah back a year ago, August. And then we were living in a little townhome in Highland for a while until the pandemic hit and the kids came home from school and we're like, we got to buy a house. So we just bought a house back in May. And so I think we're here for good. We're in Highland, which we really like. And I started my company, Evidence Systems, about 3 years ago. I left Capital One, where I was on the Technology Fellows team at Capital One doing bank stuff, building bank tech, which was cool. Capital One was pretty cutting edge on some of that stuff. And Capital One has Clojure in production. So that's pretty neat. Primarily Java shop. They've got a bunch of Go nowadays as well. Obviously a ton of JavaScript and iOS and Android stuff. But yeah, we have Clojure, or we had Clojure in the stack at Capital One. So I left Capital One, started Evidence Systems. That's why we relocated. We're looking for a better geography for our company. So we really like Utah. The Silicon Slopes here, kind of northern Utah County. Yeah, it's been a good move for us. So my background, before I was at Capital One, I was at various startups and things. And prior to that, I was at Cognitect, or Relevance. I joined Relevance back before Rich joined Relevance, and we renamed it Cognitect. So I worked with Stu Holloway and Rich Hickey on Datomic. So that was my thing for my gig for a couple of years, was working on Datomic full time. I contributed to Clojure script compiler and standard library before it went public. So got to work on some of that stuff at the very outset, which is fun. Yeah, I worked with some great people at Cognitect, really great. David Nolan, Chris Redinger, Tim Ewald, Craig Andera, a lot of really good folks, Paul. So yeah, a lot of really good folks at Cognitect that you may know of. They just got acquired and I was a shareholder. Yay. That was pretty fantastic. Did not see that coming at all. All of a sudden, Rich and Stu were like, hey, Stu and Justin were like, hey, we want to talk to you. I was like, oh, okay. I don't know, anyway, give us the good news. That was pretty exciting.
Nice.
So yeah, that was great. And that gave me sort of a basis, especially working on Datomic really gave me a basis in really thinking in terms of immutability, right? Thinking about immutable record keeping first as a default. Datomic, I didn't think about it really at the time, but shortly after I left Cognitect, I realized Datomic is this really cool event sourced system with CQRS. And that's what gives it a lot of its superpowers, is that reads and writes are decoupled and everything's immutable. So you can cache, in the peer and then in memcache and then on the Datomic server itself and all that stuff. So there's, having storage separate from the transactor, the single writer. Again, that's like very CQRS and event sourcing. So that got me thinking about some of these patterns and sort of, pressed itself onto my mind. And I was young and impressionable. So everything since then has sort of accreted on top of this foundation of thinking about things in that way, in that kind of CQRS and event sourcing way. I love Datomic as a database, but it's still sort of fundamentally down at the data level. You're still talking about nerd stuff, right? Stuff that only we software engineers care about, right? Types of fields and attributes and all that stuff. Like, eventually, I think the business people care about that, but mostly they don't. So I came to believe that there was sort of this layer above the data domain that are sort of out in business event land. And thinking about systems in terms of these events is what shaped a lot of my current thinking. So thinking about, the business events, and then everything else is a consequence of that, right? The databases, all the again, the nerd stuff that we do kind of down below to keep records and make sure everything, do all the bookkeeping stuff. That's important, but it's not primary. The most important thing is kind of this domain of events. So I just jumped right in, Brian. I realized that I'm like launching into my talk. Is that okay? Or did you have other business you want to take care of before?
Yeah, I think that's good, actually. I was thinking about that as you're talking, and I apologize for kind of launching you into that. I had forgotten where you had worked previously. So I was thinking, oh, crap, save me from a brain freeze, please. Was really the motivation for that. But Yeah, I don't think we have any kind of standard business right now, unless anyone has any announcements that they want to make at the start. And if not, I propose we just head right into it.
Sounds good to me.
Can I get you to enable screen sharing on my end, Brian?
Yeah, absolutely.
And I'm fine with recording if that's a standard practice you all do. I have no problem with recording talks.
Yeah.
So some speakers get finicky about that, but I'm not. I'm not one of those.
Okay, cool. I think you should be able to share now.
Okay. Yeah, there we go.
Cool.
Cool. Can you see my screen?
Yep. Awesome.
Editors and stuff. That's proving that I actually still write code. I'm not one of those architects that stops writing code. So my current company, as I was kind of saying again before I lost track of myself here, my current company, Evidence Systems, is all about that kind of thinking about business events and business information system event first, thinking about, what's happening, what's the narrative, what's the story, what's the customer experiencing, what are they asking us to do for them, what are we doing in response to those requests, what are we, how are we integrating with our third-party partners, how do we exchange data with them, all that. All of those things I think are best viewed through this sort of event-driven lens. So Evidence Systems is that idea, right? It's about making systems that are transparent, that document themselves, that tell you what's going on inside of them, rather than sort of opaque systems, which a lot of the database-centric applications that I've built in my career tended to be a little bit opaque in that way. So yeah, I'm Bobby. Thanks for having me here. I'm super excited. I want to continue going to this meetup. Really pleased to be here, and that there's a really great and functional and healthy Clojure community here, which is great. I have a wife and 3 kids. That's what I do in my spare time. My company, Evidence Systems, we just launched a product called ONote, which I'll talk about towards the end of the talk. But that's what I do most of my time now is run this kind of software as a service product with ONote. But we also do professional services and helping companies build these kinds of systems. And this story that I'm going to tell kind of at the beginning of the talk comes from one of those professional services engagements where we were helping a big company build a system. I like Apache Kafka. I think it's a really powerful system. It's not the only system that does this or that you can use for this purpose, but this is the talk I gave at the Kafka Summit. So you're going to see a lot of Kafka in here, but that's a late bound choice. You don't have to worry about the technologies until you have a firm grasp on kind of the concepts and the architecture. And then there's a lot of technologies that'll kind of fit the bill. A lot of people think about Apache Kafka in terms of big data stuff and machine learning and AI and streaming ETL and all these kinds of back-end data oriented things. But really, I think that Kafka is well suited to building apps, being kind of the data store of record for building applications and services. So this is a talk about kind of using that that tool set up higher in the stack where you're closer to the end user. And we had this customer, Evidence Systems customer. We were working with Confluent. We are a Confluent partner. So we were working with Confluent on this engagement. Giant company, big tax preparation service based in the Midwest. They were rebuilding kind of their tax platform and set of applications that did their kind of tracking and monitoring of a tax return through the kind of workflow. So this is like core to their business. It's a huge thing. They had at the very, very core of their kind of tax lifecycle service, they had this Kafka-based thing that they had built, 5 years ago, and it was starting to show its age. And in particular, the events that the system was getting from all over the organization, those events were of sort of dubious quality. The quality left a lot to be desired because these event publications were sort of always an afterthought. So this core data team had to sort of recreate a lot of context from the crappy events that they were getting from everybody. So they got, this core team, and then the teams that they interacted with sort of all got together and they're like, hey, let's think about building an ecosystem of kind of event first apps or event sourced apps and services so that we can, so that everyone that's publishing these events kind of eat their own dog food and think about building these things first, rather than, these events or these notifications being kind of an afterthought. So that was kind of the motivation for them. They wanted to have more fidelity around their data. They wanted to have a better understanding of what the customer was experiencing across their channels. So if they're on the website and they're on the phone with customer service rep, or they were on, they walked into a branch to get their tax return looked at, they wanted to really understand a customer's journey across all of those channels. And event first application design does that really well. For a couple of reasons. So first, event first thinking is sort of more natural. So certainly for customers, but also for business domain experts, our brains are really designed for stories. They're designed to store narratives. We think of things in terms of cause and effect. We think, this happened and then this happened, and both of those things in some way influence this third thing happening, right? We think in terms of cause and effect. And sometimes that leads us astray, right? Sometimes that's not great, when you're trying to do scientific analysis or statistical, causal inference and that sort of thing. But look, those are the brains we have, right? So we think about things in terms of narratives. So in some ways, the way that we engineers have been trained to think over the last, 40, 50 years is actually really foreign, right? That's probably why we don't get along well with like regular humans, right? Is that our brains, we've sort of systematically broken them to think in terms of state and, mutation and data structures and databases and stuff. But that's not really organic to information systems. It's not organic to human record keeping for the most part, right? For the most part, in human history, when you wanted to write a book, you didn't erase an old book. You just kept writing, you picked up a new book or a new piece of paper and you started writing. The information systems that we designed before computers, financial information systems in particular, double entry bookkeeping, ledgers, these are append-only systems, and they really have this very strong notion of an event, right? A transaction in the financial sense sort of really represents an event. When you think about these systems in terms of events first, not only is it easier to conceptualize and think about as a human, but apps and APIs that use their own event, that publish their own events and then use those events to build their view of state, end up having much higher quality events to provide to external teams, right? When events are an afterthought, when they're sort of the that extra thing we have to do so that the enterprise architects don't yell at us, those events never end up being very high quality because there's very little pain by the originating team if their events aren't great, right? So that's some downstream team's problem when I publish some notification that has no data in it, right? It's just, hey, a thing happened, go look in this service or in this database to see exactly what happened. Those architectures also tend to cause API floods where you send a notification out, 1,000 people are subscribed to it, they all realize, oh, something happened, now I have to go look up at, what happened in this third-party system. That slams this third-party system with this really bursty kind of API storm traffic, which is not great for availability and a variety of things. So when you think about and design your events first, that cross-team sharing of events ends up being much higher quality. And then when you think about events first, these cross-cutting concerns that always come up, right? We delude ourselves in thinking that we're the only people that want to see our data and see what's going on in our world, especially in large organizations. Eventually, someone's always going to want to see your data, right? And our current sort of first-class solution for that is ETL, right? Application team is first class. The software engineers are first class. We get to put our fingerprints all over the data, store it in our database, however it suits our purposes. And then if some other team downstream wants that for marketing purposes, for customer engagement and outreach purposes, security and compliance auditing purposes, well, they're second-class citizens and we'll have to ETL out of our database and they'll have to recreate, the story from our polluted and missing data. Which sets up this real inequality, right? There's sort of these two separate career tracks now. There's like software engineers over here and then reporting to a completely different organization are the data scientists, you know, over here. What's the difference, right? We're both using code, we're both writing queries, we're both analyzing data, right? We basically have the same exact job. That distinction is completely artificial, driven by the fact that software engineers have first-class access to the transactional data as it's coming in, and it's their job to sort of process those transactions. And then the data analysts and data scientists and so forth are downstream of that. There's this whole engineering discipline called data engineering, which is all about taking the really crappy data out of the transaction processing database and trying to get it into a format that makes sense to the, and is useful to the data scientists, right? So all of that stuff ends up being a second-class citizen in this world where we're thinking about our database first. When we think about and store events first, which we'll talk about throughout this talk here, customer engagement, analytics, AI, security and compliance, auditing, all of those things are first class. And they're singing from the same sheet of music and having access to the same first-class events that the transaction processing teams, the software engineering teams, are using to do the transaction processing concerns. So it kind of levels the playing field a little bit organizationally when you think about these systems in terms of events first. There are drawbacks, right? Nothing's free in engineering. Most programming languages and paradigms and frameworks and data stores and so forth really do promote database first design, right? I can Rails gen a new application and have like a working blog engine in 15 minutes. And it's all like database first, right? It's all ORM. It's all thinking about, you know, how we deal with our database models and all that stuff. There has been some catch up in the tooling here in the event world. Kafka ecosystem is one of those. Redis and Redis streams. I gave a talk at RedisConf back in 2019. That was all about this as well. They have this new streaming data structure. It's really great. And in addition to sort of the tools being lagging behind in this event-driven world, it's also just not familiar to us, right? Again, we've sort of systematically broken our brains as software engineers to think in terms of, you know, the ERD, the entity relationship diagram, thinking about our data model as like, you know, the nouns, how the nouns all relate, frozen in time, like that's how we think about our systems when we're designing them. So it's unfamiliar, right? When you talk to product and development teams about designing systems event first, they're like, well, they look funny, and they're like, we don't have any methodology for doing that. Like we wouldn't even know where to start. And that's what my client needed, right? They needed a way to communicate about and think about information systems from an event first kind of event oriented way. So that was missing. They didn't have that, right? They had a ton of tools around database design. They had ERDs, they had UML, all that stuff for sort of thinking about the objects. But they didn't have any sort of intuition about the story, the narrative, how those objects get in there and relate to each other. Ideally, this language that they needed would be simple enough so that non-technical skill sets could meaningfully contribute to the design process. Clearly communicate requirements, right? User stories, some of the other agile stuff tries to get at this, and I think leaves a lot to be desired. We'll talk about that in a little bit. It needs to be specific enough for the implementers like directly to take action on it, right? So it's kind of this Goldilocks zone where it has to be simple enough for non-developers to be able to meaningfully communicate in this language, and it needs to be specific enough for the developers to be able to take direct action as a result of this design method. So it's you know, tall order. It's a hard task, and ideally this language would also reduce adoption friction by working with our brain, right? Thinking in terms of narratives, which we already talked about. That's our brains in a large way are sort of wired to think about narratives, and then also utilizing visuals, right? The human, you know, visual cortex is extremely well developed. And having a visual language really helps get out of our head a lot of the assumptions and nuances, and we can analyze it visually with different parts of our brains. So we're not the first ones to have this problem, or you know, this customer that I was working with. Lots of people have tried to crack this nut before, right? So I'm going to give you a completely biased and straw man, you know, I'm going to admit that up front, view or history of the design tools. This largely reflects my own experience, so you know, take it with a grain of salt. In the beginning, there were sort of design upfront methods. this is UML and rational rows and all that stuff. And sort of born out of the waterfall idea, where it's like, hey, let's put some engineering discipline up front. Let's really design out and really be sure about what we need. And then we'll build it, and then we'll test it, and then we'll deploy it. Problem is, like, it almost never worked that way. A lot of these methodologies that grew up in this set of in this context, in this set of constraints, like UML, were really focused on system level concerns. They're really specific. You know, they wanted to do this like magic of, you know, diagram to code and code back to diagram, this kind of full round trip engineering of these UML diagrams, which was like total magic, right? I mean, it was really high tech stuff, but it didn't address some of the higher level concerns, right? User level concerns, business level concerns, how do we integrate this system? It was really very focused on object-oriented programming and how we structure our classes and how we you know, get stuff into the database and how systems communicate and all that stuff. And it was so complex and specific, you might as well be writing code, right? Nobody outside of engineers looked at or cared about these diagrams. Maybe a very sophisticated, you know, business analyst, a BA of some kind, would be able to read your sequence diagram or read your class hierarchy or whatever, but like, honestly, nobody except for engineers were reading these things. So it just became extra engineering work, right? It was just the work we had to do before the work. And it became kind of a pain. So this philosophy, this worldview sort of suffers from the no plan survives first contact with reality problem, right? Because as soon as you get something in production, you realize, oh man, we had a bunch of bad assumptions in our design phase, and now it's 6 months later and we're testing this thing and we can't go back and all that. So then the pendulum swung like all the way over to no design up front, right? Went from big design up front to no design up front. I think this was from a sort of bad reading of the Agile Manifesto by certain practitioners. And it was sort of like, hey, you know, the design will emerge. You know, if you just get, you know, you just test code refactor, surely the design will emerge from that practice, right? If we're good enough at refactoring, we'll end up with a good architecture. Except like, I've never seen it work. Sometimes maybe within a single code base, within a single process and memory space, that might work, right? If I'm just sort of organizing my classes or organizing my functions or something, like maybe a design will emerge there. But certainly not when you're talking about like distributed systems with all the vagaries and nuances of how those communicate and stay consistent and available, et cetera. And here, you know, we're too focused on user level concerns. A lot of this is driven by UAT, right? Kind of the gherkin, you know, what the user is experiencing. And we're not thinking about the business and system level concerns like auditability and how do we integrate with other systems across the enterprise, right? It's all about sort of get something out in front of the users, see if the users like it, see if the users like it. And so you end up with sort of no design, you know, happening at all. So here's my crazy picture, the iMaze picture. And, you know, here, failing to plan is planning to fail, right? Coding in the absence of a design is really difficult for engineers. When engineers can code in the presence of a design, it's like pulling a thread and the whole thing unravels. It's really, really nice to sort of code in the presence of a design. I saw this sort of firsthand with Rich and Core Async. I was working at Cognitect at the time Core Async came out. And Rich, you know, like Rich does sometimes, he like went off for 2 days. We like barely saw him for 2 days. And he came back and he had like stubbed and specced out all of Core Async. And he's like, I read the communicating sequential processes paper and I got thinking about it and I sort of specced out the whole implementation. So he had like protocols in place. He had the namespaces he wanted. He had even like put the function signatures in place for all this stuff. And then he's like, I just need some help like filling in what these functions do. And we're like, okay. So it was really interesting because that whole implementation process was almost trivially easy, right? We had no merge conflicts because everyone was working on a different function. We had no, like major refactorings and stuff. Like coding in the presence of design, it was done in like 3 days. So it was amazing. It was like the fastest I'd ever seen a significant piece of software be put together. And that's because there was a design that we were coding to instead of just sort of like hoping it emerged from our keyboard thrashings. So I may have hurt some feelings and poked some sacred cows there. Apologies. You can yell at me now or in the Q&A at the end. Feel free. But for me, I needed sort of a balance, some sort of middle way between teleology, which is like having a goal in mind and moving towards that goal, versus emergence, which is, you know, having a complex system with a set of rules and some sort of steady state order emerges from that complex system, right? Software engineering is sort of somewhere in the middle of that, right? We have a goal, we know that we want to build something, we have a vague idea at least of what we want to build. And then we've got a lot of complexity to manage to get to that point. So, you know, you need sort of this Goldilocks zone, something that's a design methodology that's lightweight, where we can do some small design up front or just enough design up front, right? Where we go into the implementation part with an idea. We can iterate on ideas in a cheap design artifact instead of iterating in code, because iterating in code is not free. It takes time, refactoring is not free. So being able to change the diagram is a lot cheaper than changing code, certainly a lot cheaper than changing deployed code, you know, user functionality and user expectations. So a lot of sort of techniques were developed in the DDD and Agile communities to meet this need, this kind of Goldilocks thing, just enough design up front. Event storming, design thinking, and user journeys, wireframing. Some of these things are sort of Agile design methodologies, they call them. And the keys to something that scratches this itch is it needs to be, again, simple enough for all the stakeholders to understand, right? If it's just a thing that developers do for other developers, it's not as useful, right? Because while it's important for developers to communicate, developers can also communicate in documentation and code comments and, you know, doc strings and stuff. That whole world is sort of opaque to the non-developer stakeholders, the business stakeholders, project managers, you know, all those folks who need to understand what the system does or need to shape and influence what the system does. So we want a common ground where all of these parties can come together and communicate about what the system's supposed to do. Again, it needs to be sort of well specified enough to be actionable by the implementers, right? It can't be so high level that it's just hand wavy smoke and mirrors to make the boss happy, and then the coders go away and do the real work, you know, down where everything's gritty and complicated and dark. And you know, we've got to really solve all the thorny issues, right? So there has to be sort of a coming together of these two worlds. Ideally, both the process of generating the artifact and the artifact itself are valuable. So in a lot of these things, design thinking in particular, event storming at some level, the process, the workshop is super valuable. There's a ton of like tacit communication going on and context being exchanged from developers' heads to business people and vice versa during the workshop. And then everyone goes their separate ways after the workshop, and you're left with like this big piece of butcher paper covered in sticky notes. And it's like, oh, well, the artifact leaves a lot to be desired, but man, the process was great. And I think we're, you know, better off for having done this, but this artifact is kind of useless. On the other hand, there's sort of, again, kind of the UML thing where the artifact itself is somewhat valuable, but the process of generating it is like, you know, one developer sitting by himself or herself writing this diagram, right? So ideally, in a good lightweight design method, both the workshop and the collaboration to generate the artifact and the artifact itself will be valuable. The last key is that the artifact needs to be valuable throughout the software development lifecycle. If it's only valuable during the kind of design iterations, and then it gets thrown away or never looked at during implementation and operations, it's going to fall out, you know, it'll be a lie on day 2 of the project, right? It'll fall out of date and so forth. So if it continues to provide value throughout the software development lifecycle, there will be a strong incentive to keep it up to date and keep it reflecting reality, because it'll keep providing value throughout the, you know, through operations. So for me, a technique called event modeling strikes this balance. Event modeling was invented by Adam Dimitruk, and he is a special technical advisor to Evidence Systems, so I work closely with Adam. He had a lot of input from Greg Young and continues to get input from Greg Young, who's a colleague of his. And he's the one who sort of coined the term CQRS and event sourcing. And it has some things in common with event storming and wireframing and design thinking and some of these other things, user journey mapping, but really sort of picks the best aspects of all these things and comes up with something truly unique and great. I really encourage you to look at eventmodeling.org. Adam's written some really great stuff that sort of is the canon of event modeling and how it works. And this is what event modeling looks like. So when you're designing systems in this sort of event first immutable assumptive way. This event modeling diagram is sort of the output. This is what it looks like at the end. And we'll go through each of the aspects of this and kind of show you how it works. So in event modeling, there's these 4 words in the visual language. Wireframes, also called events, or excuse me, wireframes, also called interfaces, commands, events, and read models or views. So there's kind of 2 words, unfortunately, for both wireframes, interfaces, and for read models, views. And then there's 4 patterns that emerge and sort of comprise the event models. And we'll take a look at each of these. State change, state view. This slide is wrong. Ugh. Sorry, I tried to change these slides before the talk started and the save didn't take. It's actually external state import and internal state export. And we'll talk about that in a minute. So an event, what is an event? An event is a fact or outcome recorded along the timeline of the business. So these are things that are not entity, again, sort of nerd level things where it's not a JavaScript event callback event. It's not a database trigger, right? It's something more organic to the business. It's a little higher level. It tends to be composite, something that is business meaningful. If you showed the set or a log of these events to a business person, they'd be able to say, yeah, this happens, and then this happens, and then this happens. Yeah. So these are things that are sufficient to describe a business process. We represent them on the diagram with orange sticky notes. That's why we call our product ONote. And we write them or entitle them as a verb phrase in the past tense, which we'll talk about in a second. And then we can organize these events into lanes that represent sort of independent narratives or bounded contexts. So here are the events in orange here. Registered, room added, room booked. That's kind of that past tense verb phrase. We use the past tense because this is something that's happened. It's a fact. We have to deal with it. There's no changing it. There's no rejecting it. There's no ignoring it. Like, we have to incorporate it into our view of reality. And here we see kind of the lanes, inventory, off, payment, GPS, which we'll talk about in a little bit. So these are the events. The next sort of word in the vocabulary here is wireframe or interface. And these are visual wireframes, just like you have probably done in software before. Mock-ups of the user interfaces. They don't always have to be graphical, right? This doesn't have to be GUIs. They can also be APIs, where instead of a picture, we have like a little mini Swagger specification, post to this and get to that and all that. They can be automated jobs, a cron job that wakes up every night at midnight and does some stuff. All these things are sort of comprise the interface of the system. So whatever the primary touch point is for users of the system, be they humans or automated processes, to introduce change into the system or to perceive the state of the system, that's the interface. And then these wireframes can also be organized into swim lanes, but here, instead of representing independent causal narratives, these swim lanes represent roles or personas. So here on the top, we have manager and guest. These are our 2 different personas. The guest sees certain screens. The manager or hotel staff sees other screens. The guest, has a registration screen here where they provide details just to get into the system and set themselves up a user account. They have another screen a little later here that has like this calendar thing that represents room availability. And then they've got a button that they can click after they've selected a room and a date range that allows them to book a room in the system, right? So those wireframes along the top represent kind of the user's view of the system.
Hey, Bobby, sorry to interrupt you. What did you design that in?
What's that?
What diagramming tool did you use for this?
So these are Adam's sort of original pictures of event modeling. I'm not sure what he used to build this. I will show you a tool later on
cool.
that I use now, that I wrote and use now for event modeling, that I think is better than a diagramming tool. And we'll talk about that in a little bit. But I'm not sure what he did this in. But if you go to eventmodeling.org, there's a blog post entitled "What is Event Modeling?" A lot of what I'm going through right now is sort of cribbed from Adam's original "What is Event Modeling" post. Commands are kind of the 4th our third word in our visual vocabulary. And we're also introducing our first pattern, the state change pattern. Commands encapsulate the intent to change the system and represent kind of the transactional moment, the moment where the user says, hey, do this thing for me, please. And we can be like, no. Or if everything looks fine, we're like, yeah, sure. This empowers the users to take action in the system and change the state of the system. We represent commands by blue sticky notes, and we write them as verb phrases in the imperative tense, right? It's a command. Do this thing for me, please. Register me as a user. The corresponding event might be user registered, right? But there's this moment where the user sent the command to the system, and you can be like, we already have a user with this email address, or this looks like a cyber attack, so we're just going to drop this request silently, or some other violation of invariance, at a business level, and you can respond with an error, helping the user along and so forth. So commands, again, represent the sort of transactional moment, and commands always result in the emission of an event, or in a successful case, result in the emission of an event to the event log. So here we have this book room command, and the outcome is a room booked event. And once that room booked event is written down, the state of the system has changed, right? That's the moment at which that fact becomes true. We'll talk about this in a minute. Read models may be eventually consistent and may take a minute to update or propagate, but the moment we write down this event to the event log, room booked, that room is truly booked. The transaction from a business perspective has completed once that write has taken place. Read models are kind of the fourth and final word in our visual vocabulary, and they are associated with the second pattern, the state view pattern. So read models inform users about the state of the system. They're represented by green sticky notes. We derive them from events. So read models are really just reductions or folds or transducers over a stream of events, and they represent current state. So you can totally mutate a read model, no problem there, right? The thing you can't mutate or change are the underlying events, because those represent ground truth. Those are like source facts, canonical facts. Read models are interpretations of those facts. And so you can remove stuff from a read model or update stuff in place in a read model, no problem there, because they're derived. If we want to, we can throw away a whole read model and rebuild it from source events. We display these read models in interfaces or wireframes. Again, that can be a get HTTP call, or it can be some sort of widget in a UI of some kind. And we can build lots of different read models to support the various data access patterns. This gets back to kind of what we were talking about before, where all these cross-cutting concerns are now on the same footing. They're first-class citizens right alongside the transaction processing concerns, right? Because the transaction processing folks are disciplining themselves to writing events that comprise their transaction processing domain. Now, any other interested party, the auditors, the security folks, the marketing people, can listen to those events, build their own read models off to the side without impacting or even communicating with the team that is writing these events, right? So we can build these read models to suit our needs. On the other hand, we still have this read model. If other folks across the organization want to just use our read model instead and it works, suits their data access pattern, great. They can use our read model fine, so they can either use our source events and build their own read models, which we'll talk about next, or they can use our read models the same way they do today. So here we have this room booked event. That room booked event is incorporated into the cleaning schedule read model. That's a list of rooms that need to be cleaned and prepared for guests. And then eventually the supervisor or the team that cleans the room or whoever will check off that room, like this room's cleaned, we're good to go. And so that subsequent event would also be incorporated into the cleaning schedule to remove that room from the schedule. So the third pattern here is the external state import pattern. That's kind of what we were just talking about with listening to foreign events, translating them into our local domain, and then we can build read models out of those local events. So we can listen to events generated elsewhere, either to low-level system events, Splunk metrics on your logs, or geo events in your iPhone, whatever sensor data on your self-driving car. All these are kind of low-level system events, but then they need to be sort of translated into our local context, which we'll talk about in a minute. So we can either listen to these low-level system events, or we can listen to external bounded context. We can listen to some upstream context and just listen to what they're doing and incorporate their events into our local context as well. So here we have that. In Adam's example here, this is sort of a geofencing kind of thing where when the guest leaves the hotel and it's their checkout date, we can go ahead and automatically check them out of the hotel. A little creepy, right? But that's kind of how geofencing works. You have these low-level GPS events that are just being emitted by the phone. And then you have some sort of process that's set up a geo fence around that. And whenever the phone leaves that geo fence, you emit an event saying, hey, guest left the hotel, guest entered the hotel, right? So we're translating, the important part of this example is that we're translating foreign events into our local context so that they're business meaningful in the inventory narrative. Again, if we were listening to an upstream context, someone else's application or service upstream, and we need to know when they do something, when something's happened upstream of us, we have to do the same thing. We can't just rely on the fact that they wrote it down. We have to observe what they wrote down, write it down locally in our own history, and then proceed from there. We have to write it down so that we have the whole story. Everything that's changing the state in our world has to be written down to our local Kafka topic or event stream or event log or whatever. We can't just leave it in some upstream log. We have to copy it, so to speak, over into our world. Often that copy comes with some sort of translation, right? Incorporating additional data or whatever. So that's how we get foreign state or external state into our system, is by listening to foreign events. If we want to cause change in some foreign system, we have this, this is again wrong here, sorry, this should be internal state export. And this is where we sort of build up a list of work locally. We build a little read model that represents work that we need to cause in some other system, or change that we need to cause in some foreign system. And then we have some sort of process that invokes commands on that foreign system. And then we have to write an event down locally that represents the result, right? So maybe it's the reply to the web service call, maybe it's some webhook callback of some kind from the foreign system or something. There's some, in one way or another, we need to write down locally the effects of causing that change, what happened when we called that foreign system. So Adam's canonical example here is sort of a payment processing example. User clicks pay. We write down this event saying, all right, users requested a payment. We aggregate that up into a payments to process, to-do list. This can be single piece flow. There's no problem with that. If you're writing a Kafka Streams job or a Flink job, some other sort of stream processing job, this can be done every time one of these requests arrives. We don't have to batch them up. But you may want to batch them up for some reason. Then we have this payment processor automated job here, and its job is to look at the payments that need processing, reach out and call our payment gateway, which is a foreign system that we don't control. We cause a change in that system, and then we write down the result. Either the payment succeeded because we got a success response back, or it failed, we got a failure response back. We need to write it down in either case because we're trying to cause change in some foreign system. So between these two last patterns, we have a way of importing foreign state into our system and exporting our own state out into foreign systems by listening to events and by calling foreign commands, respectively. Any questions up to this point? I've said like a lot of words and I can't see everyone because I've got my slides up. Any questions here?
I don't have any, but this is really good, Bobby. This is awesome.
Oh, thank you. I can't take credit for most of this. Again, this is Adam Dimitrich's work. Just standing on the shoulders of giants and letting you know about it. But yeah, this is it really does represent a lot of sort of distilled wisdom about systems and how they work from Adam's long software engineering career. And I found that it works really, really well for for me and for my business and for what we do, we really like event modeling. So event modeling does have a workshop moment, like event storming, like these other techniques. But the workshop, unlike some of these other techniques, doesn't have to be in person. This one that I'm photographing happens to be in person. This is us doing our kind of first few steps of event modeling here. But it doesn't have to be. It works very well remotely as well. And in the age of COVID-19, that matters. You need to be able to keep working, even if you can't get in the same conference room. So the steps of a workshop, I don't think we have time to sort of go through these, but we'll maybe do a little mini one when I do the demo of ONote. First, you kind of brainstorm. You basically just get all the events up there. So the brainstorming phase is just about piling as many events on the board as you possibly can. You're trying to get input from everyone who's participating. Just get all the events up on the board. Some of them won't be events. People will not have phrased them in the past tense. Some of the events may turn out to be commands or read models or something else, but this is all just about kind of getting everything up on the board. The plot is sort of the second step, and that's where you try to sequence these events, from a pile of events into a chronological narrative or some parallel set of narratives. So that's all about kind of sequencing them. And you get them up on the board in kind of rough order. And then you interrogate the sequence going forward. Then you interrogate it kind of going backwards to suss out all the lies. The third step of the workshop is to do the storyboard, where you align wireframes or interfaces kind of above the corresponding events. So you say, okay, roughly at the time that this is happening in event land, up in user land, up in wireframe land, this is what the customer's seeing. This is what we're showing them. This is what they're doing, etc. If we have third-party partners, maybe it's an API that they're calling, or if it's a human user, often it's a UI, some sort of graphical user interface. The fourth step is to identify inputs. That's where you're sort of connecting the wireframes to commands, and then commands to your events along the bottom. So you're identifying inputs to the system, state changes that the user is causing. And then you identify outputs, where you're going to show the state of your system back out to your user. And that's where you're writing the arrows from the event to a read model, and then from the read model up to some particular widget within a UI or a GET request in a wireframed API or automated job or whatever it is. Those outputs to the system go back out, from event to read model back out to the wireframe layer. And if you see, let's see here. Well, this is as good as any. So it's kind of grayed out, which I apologize for, but if you can see here, there's kind of this sine wave flow of information, right? Information originates on a screen with the user. The user says, hey, do this thing for me, add this room. The room is added. It flows back up to this room availability read model, and then it's displayed out on the wireframe. So there's kind of this sinusoidal flow of this information from the user into the system, from the system back out to the user, from the user into the system back out to the user, because we're informing users so that they can take some subsequent action, so that they can cause some new change. So there's, if you've done event modeling right, you've got this real kind of sine wave flow. And that emerges sort of by the end of step 5 of your workshop. You should have this nice kind of sinusoidal flow of information visualized on your model. Applying Conway's law is all about applying those kind of lanes to both the wireframes and to the events. So you sequence it, or you kind of split them out into lanes and say, hey, there's actually a separate independent causal history for room inventory. And when users register or log into our system, it doesn't have any causal bearing on whether a particular room is available for rent that night. Payment, it's also kind of a separate thing, right? Just processing the payment, capturing the money doesn't impact the availability of any given room either. So we have these kind of separate stories that we can start to tease out in this 6th step of the workshop. Same thing with the wireframe level. We've got these different audiences, and we need to cater to them and split them out so that it's really clearly visible who is seeing what and doing what when. So that's Conway's law, just understanding that we do live in a world where we have an organizational structure and we have different teams and we have different groups of users, and all of that needs to impact our software in the right way. We want to sort of use Conway's law in like the judo flip way rather than just being sort of subject and reacting to Conway's law, right? And then 7 is sort of elaborate scenarios. This is just sort of a recursive step where we do the whole process again and make sure that we've really interrogated and really understand all the edge cases and the non-happy paths, you know, along the way. So elaborating the scenarios is all about finding the lies, finding the incomplete places, finding the hand-wavy moments where we breezed over something important or glazed over it. We'll do a demo here in a few minutes, kind of after we talk about the tooling. As I mentioned before, you know, event modeling in this workshop is great, but that's really focused on design. It's an important moment. It's really sets the mold for the rest of your software engineering process to have a good design up front. But this event model needs to be useful throughout the software development lifecycle. So we can talk about that a little bit. So from design to implementation, ideally, you know, a design language helps you solve some of these problems that always pop up during implementation. So event modeling does help with project management. So again, in sort of the agile world, you have this whole ritual around user story generation. And user story generation is sort of this separate thing from software design, when really they're sort of two sides of the same coin. Event modeling kind of unifies that process. Event models themselves can be sliced into discrete implementation tasks so that you don't have to have this separate user story generation exercise. It's just mechanically derived from the event model. So here we see this kind of vertical slice from the manager adding a room, that room being added, that command to event slice, that's one discrete task, right? User clicks a button that sends the add room command, probably to our web services tier, and then we write out the room added event as a result of that. And then all the, you know, invariant checking at the command processing level where we say, oh, we can't add this room, it's already exists, and all that stuff. That is sort of one discrete developer task. It has clearly defined inputs and outputs. You can even start to sort of generate test cases directly from these models, because we know, you know, given these two things happen in the past, when this thing happens, then this third thing should happen, right? So we can start sort of mechanically deriving tests and specifications and definitions of done and you know, acceptance criteria directly and mechanically from the model without having a separate user story generation process. Same thing here with the state view pattern. We have a room added event. We incorporate it into the room availability read model, and then we display that read model in this particular UI widget. That's one discrete developer task. So you can slice this diagram up into the set of tasks, and then you have the set of covering tasks of everything you need to do to build the system. You know, of course, you're going to have separate side tasks and DevOps crap that you have to do to get this system into production. But in terms of feature completeness, the event model is sufficient to describe a feature complete system. So that helps us, you know, accelerate our implementation a little bit, helps the project managers, frees up their time. We can also accelerate implementation by, as I said before, generating test cases from these patterns, doing code generation and schema specification. So we can start to look at the data that's required. Okay, the data that's on this wireframe, all the fields in the form, get sent as this add room command and then written down as this room added event. Is the information complete? Is it sufficient? Do we have everything we need to know at every given point along that chain? So you can start doing this kind of information completeness audit, either automatically, you know, through software tools or just, you know, manually from the diagram. As you move from implementation into operations, the event model can be used for data discovery and integration. So the set of event models that comprise your organization or your set of teams starts to become a map of what data is available and who's producing it, what types of events are available. If you have an automated system like the one I'll show you, ONote, here at the end, you can start to integrate with your data platform and say, hey, you know, this lane of events represents a Kafka topic, and we know the schema for all the events that are going to be written down in these lanes So we can start to integrate with the schema registry. And this ends up becoming sort of a data discovery mechanism where we can say, just like our API gateway knows about all the Swagger specs that we've published, our event modeling platform can know all of the events and streams of events that we've published so that I can import them into my event model and build read models from other people's events. So it starts to become this sort of data dictionary across the enterprise. And then it also facilitates integration among applications, right? We can see by looking in someone else's event model when important things happen upstream of us. We can see what data is available for a particular analysis if we want to do a marketing campaign, or if we want to do some sort of audit. InfoSec and compliance auditing, InfoSec people love event modeling because it shows you very clearly who sees what information, where, and when, where it's recorded, what processes are handling it along the way, right? So we have this real clear InfoSec flow of where the data goes. During incident management or design review within the enterprise, having the context of the system design out of the developers' heads, out of the code where it's largely opaque, and in a design artifact that's clearly comprehensible to security professionals and enterprise architects and those sorts of people really help, right? In an IT incident, if Brent's not on the call, Brent from the Phoenix Project, if you've read that book, if Brent's not on the call and he knows where all the bodies are buried, we might not be able to find what's wrong in this production incident until that person joins the call. If we have those things written down, if it's visual and clearly identifiable, okay, it's this part of the system that's not working. It's this command to event path. Somehow we're not writing the event properly. That scopes the problem really clearly, gets that context out of the heads of the developers and into a shared artifact. There are challenges for doing this. I'll try to go fast here because I've been talking for a very long time. You want to have a diverse skill set in your workshop group. You want to have, of course, software people, UI, UX designers, obviously, and user advocates, sometimes users themselves if it's an internal capability and you can get users, business SMEs. And you want to have sort of 3 levels of the org chart. You want to have the people that are doing the work, their bosses, and their bosses' bosses. Analog versus digital, again, in the COVID era, this sort of matters, right? Modeling with sticky notes and Sharpies is great, but the artifact is hard to capture. At the end of it, you've got this big piece of butcher paper covered in sticky notes with Sharpie lines connecting everything, and it's hard to capture and digitize for implementation, and it's fragile. You try to move it and all the sticky notes fall off and all that. So digital is probably a better way to go, especially if you have to do remote, right? Obviously you need to have some sort of tool that facilitates collaboration, this kind of workshop format. Tooling, kind of the current state of the art is collaborative whiteboards, Miro, and there's a whole bunch of them. These sort of collaborative whiteboarding tools, they're fine. They allow you to draw a picture, but they don't scope and constrain the modeling canvas to ensure that you end up with a valid event model. You can just draw sort of any arbitrary picture. So it doesn't help beginners to get good at this. It also doesn't help kind of in the implementation operations thing. If you use a collaborative whiteboarding tool or, OmniGraffle or whatever, it is just a picture that's going to sit on the shared drive and no one's going to look at it again, unless it's integrated with your implementation operations practices and tooling. It's not going to be upgraded. So Evidence Systems, we built our own event modeling platform. It's free, you can sign up. We're about to launch collaboration next week. Next Thursday is when we launch our collaboration feature. It's real-time collaboration. And I'll show that to you here in just a second. Event modeling is fantastic. It's a great way of thinking about systems. Even if you don't end up implementing an event-driven event source system, event modeling is still valuable because those events are there. Right now, they're tacit, they're obscured, the events are ephemeral, you forget about them, your system doesn't record them, but they're there and they're important. So even if you don't end up designing the system in an event-driven way, event modeling is still a really great way of conceptualizing and thinking about information systems. And it remains useful across the software development lifecycle. That's it. That's my talk. Sorry, that was like really long. It was a much longer talk than I intended giving, but I got into it and it was interesting. So questions so far?
Yeah, awesome, man. That was good. You're actually right on time. You ended at exactly 8:03.
Great. If anyone's interested, I can show you ONote, our event modeling platform. If you've got to drop, totally understand that. No problem at all. Can I take 5 minutes and do that?
Oh yeah, absolutely.
Cool. So check out own.com. That's where you sign up. Click the big link in the upper right. When you get into the system, here's the hotel booking system that I just showed you, but this is done out in ONote. So when you start, it looks, more like this, and it's, small things. So you can drag events up from the palette at the bottom. You can either add it to sort of this unaffiliated space where it just does its thing, or you can add it to one of these events, but you can't add it to like the upper parts of the diagram where it doesn't make any sense. So again, the modeling canvas is constrained, specific and opinionated around event modeling. You can add lanes of events here by clicking this button. Same thing with interfaces. You can add lanes of interfaces up here. We can drag interfaces up to the canvas, and we're brought into this kind of separate interface editor here. We'll make a GUI first. And we can sort of add, text inputs, email, password. So we can, really quickly kind of wireframe out these user interface things. We do plan in the future to integrate with the really great set of wireframe tools that are already in wide use. Sketch.app and Balsamic and all of those, we do plan to integrate with those. So instead of using our kind of homegrown bare bones interface editor, you can use something a little more professional. As I mentioned before, interfaces don't have to be graphical. So if we say, we want this to be a REST interface, we can say, we can have this be a web service instead. And instead of widgets, we're dragging, gets and, posts, etc. So we can, move these around. And then, we can have read models, feeding the gets, and then the posts and other side effecting verbs can cause commands. Oops. Okay. Still have a few little bugs to work out here on the interactions, but you get the idea. All right, so that's kind of how you do the event modeling process. As you see here, you end up with this sort of spinal column, the central nervous system of read models and commands along the bottom here, or along the center. On the bottom, you have your events that you're writing down to Kafka or Redis streams or whatever. And then on the top, you've got all your wireframes. If you double click on this, you can edit the details, including schemas. So schema management is something that's coming soon, where you'll be able to associate very specific schemas with each command to specify the data that's conveyed by this command, the data that's recorded in this event, the data that's exposed by this read model. You'll be able to sort of specify those things in schemas. And then once you have all those schemas specified, you can start to generate code, generate Open API Swagger code or GraphQL code or gRPC code. And that's basically just taking these commands and read models and, outputting a Swagger specification that that conforms to the schemas you define. So that's a great way to sort of accelerate the integration or the implementation process. We do plan to very soon add the sort of project management feature where we integrate with Jira or GitHub issues or whatever, and you click a button and we carve up your event model into discrete tasks. We put those tasks in your task management platform, your project management system. And then as you burn those tasks down in Jira or wherever, we can reflect that in an overlay here in ONote and show you, all the things that are grayed out are things we've already done, things that are still in bright colors are things we have yet to do. So you get kind of a visual status report for stand up or for shown to the boss or whatever, you can get a clear sense of how far you are into system completion. We do also plan to integrate with Kafka and Cloud data platforms to integrate these lanes of events, because we have the lanes, we have the events, we have their schemas, so we can start to integrate at a data platform level and start to do monitoring and showing operational metrics here of how many of each event is being written and how fast and all that stuff. So there's a lot we plan to do with this that'll make it useful kind of throughout the software development lifecycle, as we said before. And as I mentioned, collaboration is kind of the next big feature that we're launching. So that'll be on November 5th. We have a webinar, and I'll try to find a link for that and drop it in chat, but we do have a webinar for the advent of the collaboration feature. It'll be live real-time collaboration. Everything that you see at this point is all local. So it's all stored in your browser's index DB, and the collaboration is all peer-to-peer. So we don't see any of this data. ONote doesn't see any of this data unless you want us to. Then you can push it to our repository, which acts kind of like GitHub. But it really is like a local first application. So I may give a talk about that in the future at a ClojureCon or something about what's required for kind of that real-time collaboration stuff. So anyway, that's ONote. Check it out. It's free. And we really wrote ONote to scratch our own itch. We were doing a lot of event modeling. It was super successful for our own internal products and also for our professional services customers, but we didn't have a tool that we loved for doing it. So we made our own, and that's kind of where ONote grew out of, and it's sort of become a success on its own. So we're pleased about that. So that's it.
That's awesome, Bobby.
I had some questions.
Yes.
So first off, so I work at BYU with a number of professors, but one of the professors I work most closely with specializes in system control theory, where my projects with him are about event systems. And so your presentation really spoke to me. It was fascinating. One of the things I was hoping you'd maybe tell us about, if you can do it without being a whole other presentation, is how the event modeling approach for you tied into the development of ONote. Like, how did you do that?
Yeah, so we actually do, maybe you saw it on the front screen there, but we do eat our own dog food. We use ONote to build ONote, which is sort of weird and meta. But yeah, the collaboration feature in particular was really tricky. And so to figure it out, I modeled out the signaling service. So the signaling service is the thing you have to communicate to before you establish a peer-to-peer connection in order to do the handshake to establish that peer-to-peer communications. So this is just one example, but I modeled out the signaling service in ONote and then started to build it for ONote. So again, it's a super meta thing, but yeah, we use it there. We certainly use it in our own professional services work. We're in negotiations and discussions now to sell off a prior thing that we built, like a prior product that we built was very specific to the financial services domain. And we event modeled all of that too. So yeah, we like it for modeling our own stuff, as well as thinking about information systems in our professional services work.
So did 50 of you get together for your first meeting and start putting together the butcher paper and the Post-it notes, or how did the process go together?
If only I had 50 engineers at my command. But mostly this is me writing this by myself. I do have a couple other contract engineers that I've worked with in the past as well. But no, I wish we had been able to do that. I facilitated sessions for many companies, some local. So a pharmaceutical company up in Salt Lake, some of you may know, did some work with them on event modeling, hosted a big workshop. I think we had like 50 people there. It was big workshop. Those workshops cover a lot of ground really fast and sometimes don't get as focused as you might want. But they're a great start. You get, some sort of rough event models across a huge domain. And then with individual teams of 5 or 10, you kind of zoom in and complete the model like all the way to ground. So that's kind of how that works. But no, for my own poor evidence systems internal products, I don't have 50 engineers to command.
Tori just made everyone very jealous here tonight.
Yes, I am hiring, incidentally. So if anyone wants to come write Clojure with me.
Yeah, and for the record, I don't have 50 either, but I was just throwing it out there.
So, Bobby, I guess.
Hi.
Oh, sorry.
If I may, Bobby, good presentation. Thanks for that. I have a practical question about event source systems. It basically depends on the size, but I imagine at some point you have to start dropping some events that basically like pass the retention period or such, because otherwise you start having problem with disk space and like how many of those you can store actually, and also then all the derived events would take a long time to generate unless you kind of materialize them and store them. But should you need to regenerate, that will take a significant amount of time. So any kind of rules about that? Like, obviously this will be business specific, etc. But how do you go about that?
Yeah, great question. This question comes up every time I speak about event sourcing. And sort of the short answer to that is snapshot. So in almost every business system, so in the financial domain, which I'm most familiar with, we close the books, right? Every month we close the books. And so every month we have a firm starting point for then, playing forward deltas of events. And we keep the events around for 5 years or 7 years or whatever the legal retention hold is. But, at the end of that retention hold, they can safely fall off the end and disappear because you've got a reconciling business event that happens periodically. I would advise against doing it just for technical reasons, right? Disk is free, processor is almost free. So, for purely technical reasons, I'd advise against it. But in almost every business domain, there's some sort of notion of a snapshot or a closing the books every month or something that will allow you to do event sourcing, but also have these checkpoints where you have stable state that you can play forward from. Does that make sense, Michael?
Yeah, it does. Yeah. Thanks.
Sure. Someone else had a question, I think, too.
Yeah. I mean, I guess what would you say is and maybe you said this in the talk in different ways. I was kind of checking out this book along the way called Building Event-Driven Systems. So I think it's a new release from O'Reilly by Adam Bellamar. But so the thing that I had heard from some people about you and about just the theory of the benefit of this kind of architecture was essentially performance, like massive throughput enhancement and having kind of like a smooth sort of data flow that's closely modeled, essentially, like you said, to your domain model. But what I was getting, like my extrapolation of what you said tonight was that it's more about the benefit that you're currently pursuing is more to do with like the actual modeling of your code and to model it as events.
Yeah, so there are definitely performance benefits, right? As soon as you relax the constraint of synchrony throughout your system throughput goes way up in sort of unexpected ways. But that has more to do with sort of synchrony and like kind of nerd level concerns of data throughput and stuff. Those do bear out in CQRS and event source systems in some ways. You have corresponding performance reductions in other ways, and now you have to deal with like eventual consistency and a few things. But yeah, a lot of those performance things happen as a result of asynchrony. The other thing that happens is that when reads and writes are handled separately, you can scale them and operate them separately, right? So many systems are like 80% read or 90% read and 10 or 20% write. So you can scale and operate the read half of your system, the write half of your system differently. That's what you do in Datomic, right? You have the storage system and the caches out in front of the storage system that are all about read. And then you have the single transactor, which is all about write. And the performance characteristics of the two are independent. You can kind of tweak them independently. So those are some of the benefits there. I honestly don't super care about those benefits for my purposes, right? Because the time that it takes to design and implement a system, and the cost associated with designing and implementing the system almost always dwarfs any given sort of performance enhancement at runtime, right? Like you're talking on the order of, you know, months and years to design and implement and deploy an information system, which is costing you millions of dollars. You know, any given performance you know, tweak or enhancement, you know, maybe you're making back pennies on the dollar every request or something, right? But so for my purposes, I think the economic benefits of conceptualizing your systems in terms of events and the business benefits of communicating with other teams and with other skill sets is sort of the dominant benefit. But yeah, there are these sort of runtime performance benefits that you can eke out as well.
Okay, cool. Yeah, thank you.
Any other questions? Come on, I talked for a long time, told a bunch of lies. Someone's got questions.
So your company's hiring. Where can we point people to for that?
Bobby at evidencesystems.com or Bobby at onote.com is a shorter domain. Just shoot me a text or an email or chat or Twitter. I'm Bobby Calderwood on Twitter.
Hey, Bobby, I got a question.
Yeah.
Hey, first of all, thanks for the talk. It's really enlightening for me. I'm just wondering, you know, kind of on a high level, like, do you find what sort of industries or products do you see kind of, you know, maybe adopting this kind of a design approach? You know, I'm in the tax and accounting world as well, so I find it, you know, I can actually see the benefit of being a little bit more vigorous in the kind of the planning in the events. We are kind of under hood event driven, you know. So I found this very, very useful. And you know, it's just two of us here. So, but even that vigor in designing, I think, is beneficial. So thank you for that. And I was just wondering what you see, you know, in the broader world. You know, what you know, obviously banking you've done, but what other, you know, places?
Yeah. So I can't speak to a ton of industries. Most of my experience is in finance, so banking, tax. All that stuff sort of really has a natural sympathy with event driven, because that's how bankers think, right? They think in terms of ledgers and all of that. Exactly. I do think there's still an important business event layer, like north of the ledger, because up at that layer, you're talking about user intent. You're talking about, you know, composite events that may result in several transactions happening at the ledger level, but they're written down as a single event. So I still think it's really valuable in a financial use case to capture those business events even before they hit the sort of core ledger or the general accounting system or whatever, your general ledger system. I've seen it work in healthcare. There's a couple of healthcare companies we've worked with that like this and use it. But you know, for my money, any system that I start writing, I'm going to default to this. And then when it gets painful, or if I hit some sort of thing that really is CRUD, like it's CRUD and there's no nuances and no workflow and no entity lifecycle, it's just making and creating and deleting stuff. But you know, sure, I'll use Redis or something for, you know, easily writing that stuff. But almost always, and this has been sort of the recurring theme in my career, is the use case looks like CRUD from the outset, and you get into it on the third day of analyzing the system, you realize that each entity has a life cycle, has a distinct life cycle. It's got its own state machine. It's got, you know, and the state machine is hidden and implicit and scattered all over the code base and all over the database schema. And so no one clearly conceptualizes what that workflow is, but the workflow is always there. And almost always the workflow is the most important thing.
Yeah, I'll just pop in and say, you know, I'm in the online dating business, and our company's been going for 20 years at this point. And one of the things that's really helped us figure out how to be more successful is figuring out how to talk about our business in an event modeled way. And now every new initiative we create, we look at it from the point of view of events, very much in the way Bobby was describing. We're not that formalized yet. I think it would help us a tremendous amount if we actually did formalize it that way. But certainly, you know, everything about our system, from members signing up to, you know, doing various things with their profile, to us approving them, to them interacting with other members. There's the whole payment cycle. Everything really about our system is event driven. And we are more and more talking about it in an event-centric manner nowadays.
Yeah, thanks, Sean. Yeah, I think actually, that speaks to the very beginning of your talk, Robbie, how it really matches the human mind more about how we think of our stories, and it's not a database, right? Yeah, of course there's a database in there, but we think in other ways. So thank you very much.
And my cliche saying that I said for a couple of years there was, businesses are not databases. Businesses are event stream reactors, right?
Yeah, they're organisms.
It's like an organism, right? You've got your cell membrane at the edge, and observations that you make about reality outside of the cell membrane are just events, right? You write those things down, and of course you're going to keep a snapshot of the current state of the world because you have to, right? Like you keep that around for operational efficiency and queryability and for different data access patterns, of course. But those things are almost throwaway artifacts, right? These are derived artifacts. The core truth is what you're observing about reality and what you're sending back out into the universe, right? So it's, businesses are not databases. And unfortunately, we first we form our tools, and thereafter our tools form us, right? And by thinking about databases for so long in business, they started to shape the way we thought about things, right? We think about a business service as a database. It's a state of things. It's like, well, it's not, right? Because in addition to writing stuff down to make sure that I'm keeping the books and understand the state of the world, I'm also reaching out and notifying my users about stuff, and I'm calling out to third-party services, and I'm, sending tax forms to everyone at the end of the year. There's all these sort of non-database things that end up in balance being the primary aspect of the user experience. So having things as events as your native tongue makes all those things sort of trivially easy and doesn't vastly complicate the state management transaction processing bit. It does, it adds a little bit of work, right? You're going to eventual consistency. You've got to think about how we're incorporating state or incorporating events into our read models. So it's foreign, and it does add one layer of indirection. But for that one layer of indirection, the burden that we impose on ourselves as software engineers and transaction processing experts pay huge dividends downstream for our colleagues in marketing and audit and compliance and data science and operations and security, because they all get to see, what we're doing without having to ETL out of our database, right?
That reminds me of, I've read some of your stuff on, or, some of the introductory stuff on Datomic and how, Datomic allows for that, kind of extra view, or I don't know, I'm not using the right terminology, right? Not having to process, maybe for the business analyst, the same data, right? But it's a different view. They have a different understanding of that organism, but having that ready at hand, is, it makes a more holistic view of the product, the company, and the service, or the organism, if you want to say so. Yeah, cool.
It gives you a free sort of a boost in maturity, your view, your own internal view of your data. You're right out of the gate, you're much more mature in terms of how you're looking at it and managing it. I guess, Bobby, have you seen that people who have implemented it, have started on systems this way? Does it give kind of a more innate capability to evolve the system as the data changes, or as other things change?
Yeah, so there's sort of two types of change in a system like this, in an event-driven system, and they happen at very different pace. So there's changes to the business events themselves, which are very rare. So in banking, it hasn't fundamentally changed since the 1400s, right? It's still the same set of fields, plus a few extras for online banking and ATMs and stuff. But since ledgers were invented, there's really not too much that's been added. And I don't think there's ever been a breaking change in the schema of ledger, right? I think it's all been forward and backwards compatible. So business events should change very rarely because business domains change rarely. If they do change, that you should change in Rich's non-breaking category of changes, where you're adding maps to the field or adding fields to the map, no problem. If you take a field out of the map or you fundamentally change the shape of the data in some way, you're going to break everyone downstream, so try not to do that. But those changes should happen pretty rarely. Changes to your read models happen all the time, right? You have a new database schema that performs better. You just, you've got your current read model v1, you just play all your events in read model v2 in production, on production data, get them to the point where they're in sync with each other, and then cut over your application code from reading database 1 to reading database 2, and now you've got a new read model in production. So those types of things change all the time, and those are the changes that with database-centric applications are hugely burdensome. It's, you know, database migrations and, oh, we're going to lose the data and we've got to back it up before we change it because we're changing it in place in the same database. Like that whole category of problems goes away in this type of a system because you can change your read models like whenever you want. You can try 4 or 5 different versions of your read model live in production, on production code, you know, sending different percentage of traffic to different read models and seeing which one gives the best results. You know, I mean, those are the kinds of things that you can start to do in this kind of a system. The other thing that your comment reminded me about, Adam, or Brian, I just called you Adam because of Abbott, Brian, is that views of state that you didn't know, like ex-pre that you needed, you can totally, you know, discover 3 months later, right? As long as you're just writing down everything you're observing about reality, you're almost certain to find some serendipitous way of using that data that you hadn't anticipated, which is fantastic, right? Elon Musk has cars driving all over the world, just hoovering in every sensor that they can pull in and sending that up to the internet and, you know, training machine learning models on all that stuff. They don't have a use for 5% of that data is probably how much they use that data, but they're gathering it all because they know that they could use it at some point, right? The same should be true of our systems. If you begin in this, like, again, super teleological way where you're like, here's our database schema and this represents all of reality, and you know, you're almost certain to be ignoring or driving past all kinds of really interesting stuff, and you're not writing it down anywhere, right? So if you're just writing down all your business events, you're almost certain to find new and valuable uses for those things that you couldn't have predicted before you wrote them, right? Which you can't do with database schemas. You just simply can't, right?
Yeah. Yeah, it's interesting. It's like my project at work right now, I realized, so I'm doing DeFi, basically like transaction modeling. And we didn't think we would need this sort of token transfer information. And it turns out, like, it's a very, when you look at the data model, it would be like, why do we need this in modeling the main transaction, right? It's the token swapping, like, it's very atomic. It's like, it's an elementary particle. And it turned out you can't do it without it. We had to go back and read. It's like, oh man. But I basically designed it essentially like it's effectively a database schema. It's an object model. And then it persists and reads from JSON. But it's interesting. I was thinking as you're just saying that, it's like, I wonder what would that have looked like that, the evolution of that, had I done it in an event-oriented model. I'll have to try that. I'll have to check out your system. And
yeah, the other thing about that that exact pattern is that, and Martin Kleppman wrote a really great paper on this called Online Event Processing, OLEP, as superseding online transaction processing and offline analytics processing, right? The great split, the great divide that sent software engineers one direction and data scientists the other direction back in the 90s was really driven by like performance limitations of relational database systems in the 90s. That's like why we have 2 different career paths now. And Martin says, you know, the current reality in the post-SQL, NoSQL, you know, not only SQL kind of world is that we have polyglot persistence. We have, you know, one persistent system for our source, like metadata stuff, like the stuff you put in Datomic or Postgres. And then we have a full text index, and we have a graph database to, you know, graph the social, you know, relations. And you know, so we have this sort of polyglot persistence world where we have all kinds of different databases for different reasons. This event-driven first world plays beautifully into that because each one of those views is just a different read model off of this the same sequence of events, right? So you write the events down first; those are primary, and then you can very easily have a, you know, Postgres model of your kind of core database entities or your core domain entities, and then a Elasticsearch full text index on the big strings and a graph database, and they all just are different views on the same, you know, different reductions or transactions on the same sequence of events. So this this polyglot persistence world, which is the reality for information systems now, becomes easier to manage for sure in an event-sourced, event-driven way.
Bob, I have a question about how you built ONote, because ONote's kind of a smaller thing, right? It lives in the browser. It connects to some other stuff. A lot of what you've taught us about in prior talks and things is business domain level stuff. I've got different departments doing things. And so one of the questions I'm just kind of thinking through is, how small does this model go and still be effective? Like, does it make sense? And since you built a system like this, I'd just be interested to hear your thoughts on how you did it. But does it make sense to model a click, a keystroke, or all those events going into an immutable log? You know, how did you treat that when you built kind of a smaller system?
Yeah, great question. So generally I don't, you can and should, you know, so I have a separate sort of analytics system segment, which is great. I highly recommend segment for the analytics, the in product, you know, what are users clicking on? What are they doing in the product? It's this great event driven system. It's this big event log in the sky. But those are sort of, those aren't what I would classify as like business events, you know, transactions in any meaningful sense. The transactions we do store in Kafka. So in ONote, we have, even though it's just me and a handful of developers that kind of come and go, we have one customer service, which has a Kafka topic or two behind it, you know, serving as its data store for events, and then one that's like a read model topic that stores just current state. And we use Kafka streams to go from one to the other. So we have one for customers, and that just, its only job is to model the customer lifecycle. When a customer signs up, we use Google Cloud stuff. So Google Cloud Identity Platform sends us a notification. We write it down in Kafka. We then call out to our billing system Stripe, and we create a corresponding customer profile in Stripe. And then, you know, so that service is all about just modeling the customer lifecycle. And we integrate with 2 or 3 or 4 other foreign systems. And so the systems integration patterns in event modeling are super great for that. And then we have a separate system for monitoring and managing the state of a collaboration session. So I start a collaboration session on this model. I want to invite others to this model. So then others join the collaboration session, and then sometimes they leave, and then I close it down. There's sort of this whole maintain a session and allow signaling between the participants so that they can connect WebRTC together. And we store those on immutable logs. So we have 2, even though we're a tiny company, you know, with this one little product, we do have 2 separate services that that manage kind of those 2 aspects of the state of the system. And it works great. And it's been super easy for one developer, me, to like build and maintain. And we've had, you know, very few breaking changes. We've only been out since, you know, June or July or whatever. So it's not a huge history, but we sort of formally launched at Kafka Summit in August. And, you know, we've got like 550 users already, which is great. Super excited about that. And so far, you know, I haven't had any pager calls at 2 in the morning with systems down. Like, it just runs, everything just works. It's great. There is an aspect of the real-time collaboration and the data management of the event models themselves that I think is the subject of another talk. We end up using a CRDT, which is basically a event source system in one data structure. So we wrote a CRDT.
Did you use auto merge?
We didn't. So I actually worked, you know, I just spoke with Martin Kleppman a couple of days ago about a new library we wrote for Clojure. So it's open, it's available. No one's looking at it right now because it's, you know, we haven't blown the trumpet on it yet, but it's called Converge. So github.com/evidence-system/converge is our little library. And what it does is basically an Atom-like reference type that's backed by a CRDT. The CRDT is based on the same paper that Martin and co-authors wrote for AutoMerge. It's the Opsets paper. And we built that library from Opsets. And what that is basically, it's, you know, a self-contained data store that can be stored in the browser in IndexedDB or stored on S3 as a blob of, you know, Freshen or Transit or whatever. and it's a self-contained log of all the changes ever made to that event model. So it's sort of like Git in that way, except it doesn't have merge conflicts and a few other really nice sort of characteristics. So CRDT is great. I think CRDT really jives with this event-driven world where you're thinking about business events in a first-class way. It's just the only thing that changes is where and how you store them, right? So instead of being on an immutable log behind a cloud thing, it's local, on disk in your browser or on disk, in your file system. And then when you push it to us, then we see and can unpack the events and we can start to react to those events, et cetera. So, and then of course, those events are partially ordered on Lamport timestamps, and you have to get to some sort of total ordering so that you can play them forward, and it always converges to the same value. That's what Martin's paper, the opsets paper, is all about. So yeah, check it out. Sorry, that's like a whole other presentation that we should probably do at some point. But.
Yeah, no, this looks awesome. I'm kind of checking it out right now, and yeah, this is cool. Cool. Thank you so much, Bobby. That was a really great presentation.
Thanks for sticking around. It was, I honestly didn't mean to speak that long, but thank you. This has been great questions, good feedback.
Cool, awesome. Well, yeah, guys, unless anyone has anything else, that's a perfect place to end it at.
I just dropped the link to Converge. Here's my email.
Awesome. Your tool looks really great too. This is it ONote?
ONote? Oh, thanks.
Yeah.
Yeah, ONote is my favorite thing I've ever built.
Really?
I've worked on some cool systems and I just super love it. I love working on it. In the front end, if you're interested because you're Clojurists, it's all reframe and material UI, and that has been a hugely productive stack for us. I used to hate UI programming, especially web programming.
Right.
Hated it. And the combination of reframe, reagent and React, and then material UI has been huge. It's been such a blessing. So that's been great. We use a little library called Go.js for the kind of modeling canvas stuff, and it fits really well into a React kind of world as well.
Okay.
And then we built a bunch of our own stuff for CRDT and for collaboration and WebRTC and all that stuff. So we built a bunch of that, and it's just been really fun. It's been super fun to work on.
Nice. That's really cool. I'll check this out. I'll create an account right now and go through it. I'm excited to look at the material UI stuff.
Yeah, material UI is really great. It's been super easy to work with.
Yeah, Bobby, I started. I'm not an engineer myself, but I started with reframe and material UI, and I actually found it easier to learn than the React stuff that I'm learning now.
Yeah, it's sort of spoiling me now. Like UI programming just used to be so hard, and now it's like, reframe.
Yeah. I wouldn't have been able to pick it up, I don't think, without kind of the reframe.
Yeah, it's good. It's good.
So what do you guys use? Is the one problem I had was, and we actually had it to some extent sort of in the system I was working on a UI in Clojure script, and the problem I kept running into was everything was very keyword driven the way we implemented it, and it didn't tightly bind. Do you guys ever run into that? And do you have a solution for it? If you do, I guess.
So say the question again. I didn't quite track with you.
Yeah, so a lot of the just the different field properties, the different display properties, we were capturing them and rendering them just using keywords. And the frustrating thing would be I don't know, at least especially for me, but also my other developers that I was working with at Videra, it was I think our eyes essentially learn to, it's you learn to recognize a word by just a couple points. And so you might have typed it in differently. And so the problem with the keyword construct is it lets you do that. Right. And so, yeah, I was always that was my one frustration with the reagent reframe paradigm. I loved the whole dispatch subscriber paradigm was awesome.
Yep, very event-driven, event sourcey, and it's and CQRSE and its orientation for sure.
right? Yeah, that was great. I mean, that to me like totally changed web development, you know. But the one downside, I'm like, and I asked them about this at the con. I asked Eric Norman and some other guys about like using either the protocols or some kind of a type-driven way of representation that can be verifiable when where you have a single source of definition. And so I don't know, that was my one frustration, was like you would find like something. The one other thing we could have done to like stave it off would be to have you know, unit like some kind of an automated testing framework, which we didn't have. So but if you checked something in and like you didn't catch it, you know, maybe it was like on the third variation of that form, you know, when this drop down box is checked, the blast field, then the form changes to that, and in that map, you know, there's a keyword that's off, and you find it like 3 months later. That was my one thing. I'm like, man, I wish that part would change. I guess spec handles that, doesn't it?
You can spec those things. We don't, honestly, in ours. So I run into that problem a few times too. But the other thing you can do is just write your functions separately and then wire them all up kind of in one go, in one spot. You know what I mean? So you write your functions in one place, and then the events.cljs is just wiring up named functions from some other namespace into the reframe event stuff. That way you can test those functions independently and so forth.
Okay. Yeah, cool. I guess that's the other thing. It was kind of my maturity with that development framework was in its infancy, and it'd be cool to take another look at it.
Cool. So I just dropped a link to Converge on GitHub, my email addresses, and then we have this big launch event coming up for ONote. We're launching our real-time collaboration feature. Adam Dimitrik, who I mentioned before is the inventor of event modeling, will be at that launch event, and Martin Kleppman may also make a brief appearance there as well. So if you want to hear Martin talk about CRDT and Adam talk about event modeling, me talk about ONote, that'll be our event next Thursday.
Very awesome. Hey, thanks
Cool.
a lot, buddy.
Thanks, team.
All right, guys.
Oh, Paula's here. I didn't hear Paula's voice the whole time. Hi, Paula.
Yeah, sorry about that.
I couldn't hear me at all.
No problem. Just wanted to say hey.
Yeah, we didn't do introductions this time. I'm sorry about that. I figured you had a lot of content, though. I heard this presentation was good, so I wanted to maximize your time.
Well, thank you. This has been awesome. I appreciate it. And yeah, look forward to future meetups. This is a great group.
All right, awesome, guys. Thanks a lot. Well, yeah, I guess next month we got Jacob. I think, who is it we have scheduled next month?
Daniel Bell.
Daniel Bell. Cool. Yeah. So yeah, see you guys in November.
See some of you online before that.
And yeah. All right, cool.
Good night, folks.
All right, have a good night, everyone.
See you. Have a good
night. Thank you.
Good night.